inside the function. So for example, say it was 2x and the graph was x squared, that would be 2x in brackets squared. If it was something like sine x, it would become sine 2x. If it was something like x squared plus 4x, it would become 2x squared in brackets plus 4 times 2x. So each of the x values would be, each of the x's would be replaced by 2x. Now what this is stretched parallel to the x-axis, so it affects the x direction. But remember, this time it's a scale factor of 1 over a, and I'm going to do my best now to try and explain why that happens. Okay, so if I look at this orange graph here, ignore those blue dots for a second, okay, my input, when x is minus 5, I get 7. When x is 1, I get 7. I know here it's slightly out, but just work with me, it's 1, 7. When I've got minus 4, I've got 2. And when I've got 0, I've got 2. When I have got minus 3, I've got minus 1. When I've got minus 1, I've got minus 1. And when I've got x equals minus 2, I've got minus 2. Okay, now if I've got the graph of f of 2x, what that means is I'm doubling my input before I put it into the equation. So here, if x is minus 5, if I'm first of all going to double what I'm putting into the equation, in order to get the same answer that I get for minus 5, what I'd actually do is I'd put half of minus 5 in. So my input would be minus 2.5. And in the same way, my input would be minus 2 for minus 4, minus 1.5 for minus 3, minus 1 for minus 2, 0.5, that should say minus 0.5, apologies, for minus 1. 0 would stay the same. I'd still be putting 0 in, so nothing would happen to 0. And instead of putting 1 in, I'd put 0.5. So they are what my x values would be. And before I put them into the equation, I'd multiply them by 2. So that's when I'd get what my values of 2x were. And then when I put my values of 2x in, this is when my y values would stay exactly what they were. So nothing is changing in terms of the y values, it's the x values that are changing. So if I plot those, and I've not done my animations right, okay, but if I plot those, okay, what I would get is this one here. So this one here is minus 1, minus 1. And if I look, okay, what I'm actually plotting at minus 1 now is minus 1, minus 2, because it's half of minus 2. If I look at this one here and here, this originally is my minus 1 and my minus 3. Okay, and if I halve those x values, because I'm going to double them in a minute, I get minus 0.5 and minus 1.5. So what I'm going to get is, because I'm doubling minus 0.5 and minus 1.5, I'm putting minus 3 and minus 1 in, so I end up with the y value of minus 1 and minus 1. Here, if I've got the x coordinate of 0, okay, if I was to double 0, I'd still get 0, so that one doesn't actually change. But on the other side, okay, if I had minus 4, 2, if I wanted to put minus 4 in, what I'd actually put in is minus 2. So minus 2 doubled would give me minus 4, and then I get the same y coordinate. Okay, and then my other ones come from half of minus 5 and half of 1. So I've got half of minus 5, which is minus 2.5, and half of 1, which is 0.5. But again, my y coordinate of 7 stays the same. So if I join those up now, this is what happens, okay? So what happens here is, this is like my graph has been squished in. So I started with the orange graph and I've squished it in by scale factor of a half, okay? So I've squished it in by scale factor of a half rather than pulling it up, okay? And that's how we explain it for f of ax. So again, I'm going to look at that in terms of a sine graph with you, just because these sometimes look nicer, okay, and you can appreciate them a bit more, okay? So just let me skip back to, just let me skip back so that you can see what I'm doing. So this is, again, f of x equals sine x, okay? And this time what I want to sketch is the graph of sine 2x, or I could call that f of 2x. So here, that 2 is kind of infiltrated the equation. It's gone inside. It's not just like two lots of sine x, it's sine of 2x. So it's changing what I'm inputting. So if you think about it here, at 0, 0, if I do 2 times 0, I'm still at 0, so it doesn't make any difference, okay? But if you think here, if I've got 91, if I'm first of all multiplying an x value by 2 before I substitute it into the equation, what I'd actually be putting in is half of 90, which is 45. Here, at 180, what I'd actually be putting in, because I'm multiplying by 2 first, is 90. I'd multiply it by 2 to get 180, and then sine 180 is 0. Okay? Here I'd be putting 135 in, and here I'd be putting 360. So what actually happens here is my graph is squished, okay? All right, I know squished isn't a technical term, but it's stretched, and it's stretched by a scale factor of a half. Each of the x values has halved. That's where it comes from. So because that sine graph is continuous, we've got that shape that makes up the first part, okay? And then if I just copy and paste that, we've then got, if we were to go all the way to 720, we've got that's squished half, so we've got that shape there. So what actually happens for sine 2x or cos 2x or tan 2x, if we've got 2x or 3x or 4x, the number of oscillations, so the number of times that shape appears in from 0 to 360, okay, 2 times or 3 times or 4 times, depending on what it is. So because here each of the x values is halved, in the range from 0 to 360 we get 2 oscillations. If it was 3x, we'd get 3 oscillations, so each of the coordinates would divide by 3. Okay, the same happens in the negative. So again, it's like I've squished it in, I've stretched it by a scale factor of half, so it becomes that. And then because that graph is continuous all the way to infinity, I get that it continues like that. So again, basically what's happened is the number of oscillations, instead of having 2 from minus 360 to 360, I've got 1, 2, 3, 4 lots of that same graph. So it's each of these x values has halved, okay? One more example I'm going to look at with you, okay? So again, I'm just going to stay on this mode for you. So the blue one, first of all, says f of 2x. So just let me overlay my scribble. So if I overlay this now, okay, so if we look here, okay, this coordinate at 2, 0, okay, instead of putting 2, 0 in order to get an x value of 2, if I'm multiplying by 2 because it's f of 2x, I would halve it. So that 2, 0 would become 1, 0. This value here, 0, 1, would stay the same. So when I squish in from the other side, it will go back to that, okay? And this value here at 2 minus 2 would move, again, because I'm halving the x coordinate, would move to 1 minus 2, or about that. 1 minus 1.5, not 2. Okay, so when I squish that in, okay, if I've got f of 2x, it's squished in by a scale factor of a half. Each of the x coordinates has halved. Now if I had f of a half x, okay, here what I'm having to do here is halve the x value before I put it in. So again, if I overlay it, okay, if I was halving the x value to get 2, to get minus 2, what I'd have to put in is I'd have to put in minus 4. So minus 4 halved would give me minus 2, and then if I put minus 2 in, I get 0. So that minus 2, 0 would become minus 4, 0 there. Okay? Again here, and it will alter itself when I change the graph in a minute, but if I was to put 0 in, half of 0 is still 0, so that coordinate here will be exactly the same. If I look at this minimum coordinate here, so 2, and it looks like it's about minus 1.5, okay, 2 minus 1.5, if I'm halving the x value before I put it in order to get the same answer that I get when I put 2 in, I'd have to put 4 in. So that minimum point would stretch, okay, so that it becomes, yeah, I'll go there, so it becomes 4 minus 1.5. okay? And if you look at the places now where the line crosses the x-axis, all the places for the blue one should be halved, and all the places for the red one should be doubled. I'm just going to stretch this red one out slightly. Yeah, I'm a bit happy with that, okay? So if we look, okay, at the x-axis, so on the original graph, it went through at -2, about, say, 0.75 and 3. If I look at the blue graph, each of those is halved. So the blue one goes through at -1. It goes through at half of 0.75, so about 0.375. And then half of 3, 1.5. Okay, and you will only be asked to sketch these, so it's just kind of getting an idea. Okay, half of 0 is 0, so that point there stays the same. Here, if I've got y equals a half x though, 1 over a half is 2. So this time, because 1 over a half is 2, each of my x values doubles. So -2 becomes -4. Okay, at this point here, 0.75, okay, doubles, so it becomes about 1.5. All right, and that they are basically estimate scales. Okay, and then this one here, let's just stretch it out a little bit. Okay, this one here at 3 would become 6. Okay, so it would look something like that. So f of 2x would be a stretch in the x direction, scale factor a half, so that's the blue one. All the x coordinates have halved. F of a half x would be a stretch in the x direction, scale factor 2, because 1 divided by a half is 2. And that is how the graphs would look, okay? So I'm going to finish talking about that there, and I want you to just look at Google Classroom for what work I want you to set on this, okay? Email me with any questions, but I will do a Google Hangout to answer any questions as well. Thanks, girls.